The International Space Station is an orbiting science laboratory, and it's also an orbiting technology test site, a place where new concepts and hardware designed to improve our ability to travel in space can be tested in a weightless environment. One successful example is the apparatus called the Amine Swingbed, a system to filter and renew the air for the crew members to breathe inside their spacecraft. Recently, my colleague Pat Ryan had a chance to talk with the Amine Swingbed principal investigator, Dr. Jeffrey Sweterlitsch, of the Crew and Thermal Systems Division here at NASA Johnson Space Center, and asked how this system works to clean the air on the station.
The way that this swingbed works is there is sorbent media contained in this, basically a bed of rocks, sorbent media that absorbs carbon dioxide and humidity, and one bed is exposed to the cabin atmosphere and the other is exposed to vacuum. The way that it's similar to the carbon dioxide removal assembly on station, in the sense that you have two beds that go back and forth. The difference is we don't have to do any heating with our system, and it's a different sorbent media that's being used. We don't save our carbon dioxide. The carbon dioxide that we absorb, we vent out to space. So those are some of the differences that are between our system and the primary carbon dioxide removal system.
When you say you don't have to heat it, I take it the other system does?
Yes.
What is that, to activate the...
That's
the media?
how they regenerate their sorbent media. Our beds are designed so that the heat from adsorption transfers to the other bed doing the desorption. So it's basically isothermal, constant temperature process for us. And it reduces the energy demands.
Which is always a good thing.
Yes.
On
Yes.
a spacecraft. Now, I understand that this apparatus was originally designed to be used on the Orion spacecraft.
Yep.
So how does it come to be up in space on the International Space Station?
So it's an interesting story. We were doing a lot of testing in our facilities here at JSC, and people knew that we were doing some of this work. And so management came to us and said, we'd like to see how this would work in a real spaceflight environment. And
would you like an opportunity to try it out? Make sure it really
exactly.
works?
So we've done a lot of ground testing. We even did some testing with some humans back in the 2008 timeframe. But then we started saying, okay, how are we going to get this on orbit? Because there are different demands for running this type of equipment on space station than you would in Orion. The Orion missions, they are shorter duration. They're typically not going to be, they're going to be 20 days, 30-day missions, where station's up there for months and months and months at a time. And so the main thing is you want to make sure you save your resources as you go over and over, rather than venting continuously, which is what Orion will be doing. So we had to add additional hardware to see how to reduce our water losses and our air losses, which are less of a concern for a short mission, but are very important to know about for long-term missions on station. So there was additional equipment that we added to the system to make it more compatible to the space station environment.
And it's been up there since May of 2013, right?
We started operating it in May of 2013. Okay. We had about a year and a half worth of troubleshooting to go on, so that took some time to get that going. But when we finally got it operational, we started operating it, doing our science tests. We had about 1,000 hours of planned test runs that we wanted to do, and we finished that up back in February timeframe of last year.
How did it do? Did it work right?
It worked very nice. We had a couple of software things that we had to adjust as we were moving along, but what we found was it behaved very similar to how we tested on the ground, which produces a big boost of confidence.
Yeah. That
the design is good, and that also provides confidence to Orion, because their system is looking very similar to what we do in terms of the carbon dioxide removal function. So it gives them a lot of confidence as well. Hey, we've operated this in a real spacecraft environment. That's good news for the Orion program.
Did you learn anything from the actual operation that you can apply back into the Orion version?
There was a very unique technical issue that came up. The swing bed, the way that it works is there's basically two beds, as I said earlier, but there's a valve that rotates between bed A and bed B to direct the airflow.
Okay.
And there was a feature with that valve that we found out during our testing that that could result in an over-rotation. And the problem with that is you could now have a direct path from cabin atmosphere to space vacuum, which would be a bad thing.
Yes.
So when we learned about this situation, that was information we were able to provide to the Orion program, and they've made some design changes because of that thing that we found out. So the version that we have on orbit won't suffer that issue. This was a ground test that we tried out, and the new version is a lot more robust, and so that risk of having a direct path to space vacuum from the cabin isn't going to happen now.
Now, you mentioned you completed the testing in February of 2014. What has Amine Swingbed been doing up there since then? What's it going to keep doing on the station?
Correct. We did about 1,000 hours of test planning, and since then we've done more than 1,000 hours of actually providing contingency carbon dioxide removal systems. When they take one of the primary systems down to do some maintenance, they ask us to turn on to help with some of the CO2 and removal functions going on. So basically we are a backup. When there's requests from the flight director or from some of the console operators say we need a little extra CO2 removal, they call us up. And we operate it ourselves, not from the flight control room, but from mission control. And we just push some buttons and away we go. It's a very simple system to operate.
It'd be great to see it running in the future spacecraft too.
Yes, it will. I'm sure it will definitely be running in the future spacecraft. We are planning. We'll keep it up there as long as the space station program wants us to operate, which could be another couple years. Who knows? I don't know exactly how long that will be, but we haven't seen any changes in performance over the last 2 years of operations. So that's also, a very good thing for both the Orion program and station program as well.
That's great, Jeff. Thanks very much for bringing us up to date.
Well, thank you.
Dr. Jeffrey Sweterlitsch is the principal investigator of the Amine Swingbed operating on the International Space Station.